So hey guys, what's up? This is Kaveri and I hope that you all are well and fine and ready for the next video. In this video we are going to discuss about the law of reciprocal proportion as well as the law of equivalent proportion, which is also known by the name as the law of multiple proportion. From this video we have decided to talk topic by topic. Suppose that, not suppose, but we are going to discuss or learn somewhat new about particular topic, not about the complete chapters, so due to which you can easily get able to understand the particular topic and easily able to get the particular concept as well as. So without waiting for time or second, let's begin. Welcome back to the another new video. And as from the thumbnail you can definitely identify what's the topic for the today's video. So today we are going to discuss somewhat about the law of multiple proportion as well as the law of reciprocal proportion. So let's begin from the first topic, that is law of multiple proportion. As we have learned, as I have already discussed about the law of conservation of mass, that is also known as law of destructibility, and law of definite proportion, which is also known as the law of constant proportion in the previous video. So if you didn't watch that video, definitely go and watch that video. I will give the link for that video in the description. So without wasting for time, let's begin this new another video. So in this video, our first topic is about the law of multiple proportion. So it must be always remember that law of multiple proportion is given by the John Dalton, a famous scientist by the name of whose an atomic theory was published known as the Dalton's atomic theory. He also got a Nobel Prize for his atomic theory, as well as he also has researched in the terms of atoms, because of what he got the Nobel Prize. So what does the law of multiple proportion means? So as discussed earlier, law of multiple proportion states that if two elements combine to form more than one compound, that's so this law was stated by the Dalton. The law suggests that if two elements combine to form one or more than one new compounds, the different mass of the both of the compounds will different mass or the fixed mass of both of that compound from which the new compound formed will remain same, not remain same, but in the simple ratio, which means that simple ratio means a ratio which is simple, that is 1 gem 2 gem 3 and many, means that a ratio which continues in a same line, that is 1:2, 2:3, 2:4, 3:4, 4:5, which goes continuous. So let's take the examples for the law of multiple examples to clear the more concepts about the law of multiple proportion, which is given by Dalton. So first example we will take about the nitrogen oxide gas, that is combined from two elements, that is nitrogen and oxygen, that is single molecule of oxygen that forms N2O, nitrogen oxide. So here's the ratio for the nitrogen is the atomic weight of the nitrogen is 14, so it bears ratio 2, here oxygen 2, for 28, 28 means 28, and O2 means oxygen is molecular weight 16, so molecular weight 8, so 8 into 2, which is 16. So if we simplify 16 and 28, it forms the ratio of forms the 7:4 ratio. So it's not an example for the law of multiple proportion. So let's take the another example. Why this is not a simpler ratio, but it's unsimpler ratio. So this we cannot conclude it as the law example for the law of multiple proportion. So let's take one another example. Okay, so the another example for the to prove that this simpler ratio is for the law of multiple proportion is that the nitrogen plus oxygen, that is O2. So here nitrogen, the atomic weight is 14, molecular weight is 14, plus 2 into 8 oxygen, for oxygen, that is 16. So it bears in ratio 14 is to 16. So we can simpler it forms NO2. So it generally forms a ratio. If we can divide here 16, divide both by 2, that is 2 8s and 2 7s. So it forms the simpler ratio, that is 7:8. So this we can say that this is the example for the law of multiple proportion. This is the example for the law of multiple proportion. This what we mean the simpler ratio. So now we can take the another example, that is for the nitrogen and ozone. The ozone, which we mean that the O3, the formula for the ozone is O3. So here is nitrogen and ozone. So if we can react both of these in air, it forms the nitrogen, 2 nitrogen and 3 molecules of oxygen. So what's for the nitrogen? So the molecular weight, as we calculated previously, that the total molecular weight for the nitrogen is 28, and for the oxygen is, here is 3 molecules of oxygen. So the total weight for the molecular weight for the oxygen is, that is 48. So if we divide both this ratio, so here is 28 into 2 14s and 2 24s, 2 7s, 2 12s. So this we can conclude that 7 gem 12. This is not the example for the law of multiple proportion. What, this is not the example for the law of multiple proportion? It may be wrong. So let's move further with the one thing I forgot to tell you, that if the ratio is in the point, suppose the ratio is in the form of 1.33 gem to 2.66 is to 3.999. This is also we can write as a simple ratio. So we can take this as an example of the law of multiple proportion. Multiple proportion, as these ratios are simpler, if we can round off this figure, not round off, but we can see that here is 2, here is 1, here 2, and here 3, that it goes continuously in the form of natural numbers. So it can definitely be the example of simple ratio. Okay, so here for the topic for the law of multiple proportion over. So let move further for the law of reciprocal proportion. Law of reciprocal. Okay, so the law of reciprocal proportion is also known by the name of the law of equivalent weight. What, the law of equivalent weight? It is given by the scientist named Richter. What does this law suggest? So this law suggests that the if ratio of weights of two elements, elements combined separately with fixed weight of the third. Two elements combined separately with the weight of third element is combined separately, and the weight of the third element which is formed from that two elements will either same or simple multiple of ratio from which of both of that elements from which it is formed. Let's understand it by the diagram or by its example. The words are very difficult to understand, but the law is very simple. If you can understand it, you will never forget it. So mug up it by the example, not mug up the full words. What the proper law is, you can also write it in your own words. So let's understand this with the example of the law of equivalent weight. So here we take the example for the law of reciprocal proportion, which is also known by the name of law of equivalent weight. So here is a triangle, equivalent triangle, not equivalent, but here is hydrogen H, here is C and O. If we combine hydrogen and oxygen, means this both this and these points. So what can we find? That it forms H2O, water molecules. Hydrogen never be single, no, as it has two element to form its duplet. It has two elements in its valence shell. So here we make the reaction, that is H2 plus O2. It forms water molecule. So same way as here, if oxygen and carbon combines, it forms the CO2, as by C plus O2 forms CO2. And the last, that is hydrogen and carbon atom. So this is hydrogen and this is carbon atom. It forms methane gas, that is CH4. CH4. As we react this both. So from this example we can conclude what does the law supposed to say, that law suggests in actually. So here this take we as an example of as element A, this is element B and this is element C. So the law suggests that if two elements A and B, this A and this B, combine separately, means here we have to combine separately, that is H2 and O2, then with fixed weight, that both of these have their own fixed weight, which is if suppose two elements are combined, one box, take the example that one box of 5 kg and another box of 3 kg. If both of that box are placed together, then total weight will be 8 kg. So same we can take the example here, that hydrogen and oxygen, both molecules, both elements or atoms combines with each other and forms the fixed weight of third element. That is, this is the third element. That is the fixed weight or the total weight of the hydrogen and oxygen molecule, first and second molecule. And further, in the law it is said that the element C is either same or some multiple or some simple multiple of the ratio of the weights in which A and B combine directly with each other. So this element formed from A and B will either be same or it may be multiple or it may be some multiple some simple multiple ratio, not only simple multiple ratio, simple multiple ratio of the weights of A and B. This A and B weights, and this both has a simple ratio, that is hydrogen has 2 and oxygen has 16, that is 1:8. That is the simple ratio. From that, so here it's not the same, but we can say that it's the simple ratio. There is also another example for the same, but the law suggests that it may be same or simple multiple, that is not exactly same or not exactly multiple simple multiple ratio. It's either be simple multiple ratio, or it's either, or it may be same ratio of of the elements, that is A and B, hydrogen and oxygen, which combines directly with each other to form the element to form their respective element. Same if we take the example here that element B and C combines to form CO2, and same here as the element C and A combines and forms the CH4 molecules, CH4 molecules, that is methane gas. So by here we can complete the another topic, that is the law of reciprocal proportion or equivalent proportion. So in the next video we are going to discuss about the structure of atom. Before structure of atom, we will discuss the hypothesis of Berzelius and Avogadro's. So till now this much only, and I hope that you enjoyed the video a lot. So let's have a break. Okay, so hi guys, I hope that you all have enjoyed the video a lot, and so whatever we have studied in the video, let's revise quickly. So at the starting we have studied about the law of multiple proportion. What does that law suggest? That law suggests that if two elements combines to form one or more than one new element, then the ratio for that element will be equal to the mass of the ratio of that both of the elements from which the new element is formed. And it must be always remember that the ratio will always be in a simple form, or we can also say that both of that element combines and forms a new element, but the ratio of their weight will be in a simpler form, that is weight will be in simple ratio, that is we can say that 1:2, 2:3, 1:2, 2:3, and it goes continuous till the elements finishes. After that we discussed about the law of reciprocal proportion. The law of reciprocal proportion, which it is given by Richter. The previous law of multiple proportion was given by John Dalton. This law is given by Richter. So in this law we studied that first of all, this law is also known by the name of the law of equivalent weight. So what does this law suggest? This law suggests that if two elements A and B combines to form the third element by the fixed weight, then the ratio for the third element, which is formed by both of the first and second element, will be either in simpler form, or it may be some multiple ratios of the elements of A and B, from which it is obtained, while the A and B will always be in their fixed ratio. That is, we can take the example. We take the example for the triangular. That is, first we have take the reaction for the example of hydrogen and oxygen. That is 2:16. That is 1:8. It is not the simple ratio, but it's a multiple ratio. So it forms a compound water. But in the previous law, that is law of multiple proportion, the ratio will always be in the simpler form. That is 1:2 as discussed earlier. So we had understand that law of reciprocal proportion and law of multiple proportion. In multiple proportion, we had taken the example for the nitrogen and oxygen, simple nitrogen and simple oxygen, which bears in the ratio of 7:8. 7:8, which is continuous 7 and after 8. So that we can take as an example of the simple ratio. So till now this much only, and see you soon in the next video. If any doubt, then leave it in the comment section or message me in Instagram personally, and the link for the previous video for the law of conservation of mass or indestructibility in Dalton's atomic theory I will give in the description, and also my account's link will be available in description. So let's meet in the next video. Till that, enjoy and have a nice day. So thanks you.